Hi guys, so today you guys will be learning about Faraday's law of induction. So this is similar to the Biot-Savart law where you have a magnetic field induced from a current, but in reverse. So Faraday's law shows how a current is induced from a changing magnetic field. So Faraday's law states that the EMF, which is the electromotive force, is equal to the negative change in magnetic flux over the change in time. And magnetic flux is given by the dot product of the B field through any closed loop and its cross-sectional area. The negative sign is invoked from Lenz's law, so you should watch your video on that. So, as an example, if you had a closed loop of wire and a magnetic field, which is in this case pointing into the board with the X's, then if the loop was moved to the right out of the field, then we would see that the EMF decreases since the change in time is constant and the change in flux is decreasing since the area is constant, but the B field is decreasing as less of it penetrates the loop. So in this case, Lenz's law will show us that the current in the loop is going clockwise. Another thing to know about Faraday's law is that you have things called inductors, which are basically just coils of wire, and they act as like multiple loops stacked on top of each other. So Faraday's law, to account for these multiple loops, Faraday's law states it as E is equal to negative n times Faraday's law. So n represents the number of loops in the coil. So here we have an example where the initial state shows that a closed loop has 5 Tesla going through it and has a cross-sectional area of 4 meters squared. And over 4 seconds, the magnetic field doubles, going to 10 Tesla. So how would you find the EMF? Well, you just plug it in. So in this case, the number of loops is just 1, since it's 1 loop. And you would plug and chug, plug and chug, plug and chug, and you'd see that you get negative 5 volts. And you'd be done, but let's say you're taking a test and they wanted to make sure that you learn more stuff. So if you were given the resistance of these coils, you'd be able to find the induced current. So let's say the resistance of these loops was 2 ohms. Then you would just use Ohm's law in order to find that the current going through this loop after time is 2.5 amps in the clockwise direction. Yay!